Hello. Today I'll be presenting my presentation on rock blasting, also known as blowing things up that you want to get out of the way. If it doesn't need to be there, blow it up. First, we'll start off with the outline. We have an introduction and overview of rock blasting. It's just the general idea of what it is. We'll talk about the equipment used and costs associated. Then we'll talk about the safety of it. And then I have an example for when rock blasting has been used in the state of Texas on a fairly large project. I have a summary and conclusion, references, and questions. I have 3 questions lined up. Okay. First thing is the introduction. Rock blasting is a method used in construction, on construction sites, forming where dynamite charges are set in a particular fashion so that an area of rock can be got out of the way. So if there is a material that is too hard for, say, an excavator to be able to dig out efficiently, we'll have people go in, they will drill precise holes and drop in charges and use detonators from afar to be able to blast it out of where it needs to be, breaking it up and allowing it to be hauled off to somewhere else. So there's typically a couple steps associated with rock blasting. Your first one is your site analysis. Somebody needs to go in that is smarter than me and go and take a look at the site layout, what needs to be done, and just get an overview of what is going on there. The second thing they need to do is once they have a geotechnical engineer come out there and figure all that stuff out, they're going to start going in and drilling precise holes in a sort of, from what I've seen, it's a grid pattern, and they do it in a very calculated way in a grid so that when the explosion does happen, it is very controlled and it's easy, and it's for safety and for a more precise blast. You have charging. They're going to put explosives in it. That's the charging process. It's just dropping your charges inside of holes. They can vary in different sizes. You have nitroglycerin charges, things like that. You have blasting design that goes into it and designing how it's going to be blasted and what the explosion is, essentially predicting the explosion and what it's going to look like to minimize problems that could occur. Detonation, self-explanatory. Detonate it, watch it explode, have fun. After that, you are just removing all the debris that came out from the blast. Next, I have equipment up here. I have a couple pictures of different equipments. This is the bit that they use on the drill to be able to drill those precise cylindrical holes for charges to go down there. You have crawler drills, mobile drills mounted to tracks for maneuverability. You have jackhammers. Obviously, you should know what a jackhammer is. A DTH, a down the hole drill, uses a deep, precise. It's used for deep and precise drilling into hard rock. Explosives and charging equipment is set in there. You have your explosives that are used to create the blast, which is your ANFO, or ammonium nitrate fuel oil explosives. They also, something that I didn't put in here, but they do nitroglycerin charges. There's a bunch of different things that can go boom, and we use a lot of it. Detonators, the button. I mean, that's all it is. It's the button. You have boosters, which are high energy explosive materials that help ignite the main charge. It's your primer. That's all it is. It's a primer. You have a small explosion to make a bigger explosion. And then explosive loaders are devices used to load the explosives safely into the drill or into the drilled hole, because you probably don't want to take explosive and drop it down a hole. Not the best idea, in my opinion. The cost associated with it, and from the cost that I have been able to find, is per cubic yard, because most things, anything geotechnical and geotechnical engineering, it seems it is all done in cubic yards, and it seems to be anywhere from $50 to $200 a cubic yard. Pretty big price range there. I don't know what is accurate enough without getting an actual quote from a company, and I don't think I can get a quote from a company without something to explode. So that's that. The safety along with it, obviously you're blowing stuff up. You need to be safe doing it. Clearly mark the blast site. Have it blocked off. Like, that seems pretty self-explanatory. You have station guards at all access, including pedestrian and vehicle entrances, to prevent unauthorized entry, because that would not be fun if somebody went out there and it exploded. That just seems like a lot of paperwork and lawsuits. There's many other safety things. After detonation, you should probably wait at least 30 minutes before allowing personnel to re-enter, because explosives do explosive things sometimes and they don't explode, which is great. Not really. It sucks, and it can really cause a lot of harm. It's like finding a landmine that hasn't gone off from World War II. You probably should get away from it on the off chance that it's still primed and ready to go, because that can happen. So there's that. Conduct thorough inspections afterwards, making sure everything went off, making sure that everything is accounted for, and it should be completely safe to enter that site again, to start taking all that material that was just blown up and pull it out of there. But it needs to be safe. It's not good if it's not safe. A Texas use, which I did quite a bit of digging on this and looking into it, and it is a very interesting project. This was in 2013. When construction was happening on the Ferguson power plant in Horseshoe Bay, the team encountered a tough rock layer that needed to be gone, and conventional equipment was being used, but it could not penetrate that rock layer. So they had to call a blasting company to come out and blast the rock. Now, what they ended up doing was the company used 5,979 pounds of dynamite and around 1,541 detonators. That's a lot of equipment. And a lot of rock was removed from the area. This is the power plant, and this is what they were trying to do originally. These are pictures from them hitting the hard rock material and not being able to get through it. And that's when they realized they needed to call in the big boys. The summary, in conclusion, rock blasting is a very controlled process. It's very helpful in mining. It has been very helpful in construction, removing things. In quarrying, they use it in big rock quarries to remove a lot of rock very quickly and be able to excavate that off-site and to an alternate location. Of course, it's used by placing charges down in holes and having a precise grid layout so that everything goes safely and smoothly according to plan, with hopefully no injuries and no uncontrolled blasts that gets rid of something that you don't want to get rid of. These were my references. Nice websites and links here. And then for the questions, what piece of equipment is used to make precise holes for the charges to sit? I'll give you a hint. It's a drill. You have to drill into the rock first. It's a blast hole drill. It's pretty self-explanatory. It drills a hole so the blast charge can go in. What is the average cost of rock blasting per cubic yard? From what I can find, I might add. From what I can find on the internet, it is $50 to $200 per cubic yard. Big price gap. but it still seems relatively cheap for how efficient it is, and it seems to be very worth it. In the reference material that I looked through, the Ferguson power plant, one of the guys who's working out there said that next time they encounter that, that will be their first option when encountering a rock that they cannot get through. They'll go straight to blasting because it is that much more efficient. And then on that topic of the Ferguson power plant, how many pounds of dynamite were used in the rock blasting project at Ferguson Power Plant in Horseshoe Bay, Texas? It's a lot of explosive. 5,979 pounds of TNT. And that will sum up my presentation on rock blasting. I hope you enjoyed the presentation. I hope you learned something new. And I hope it seemed as interesting as I was interested in it, because it is pretty cool. Thank you.